Alright, so now we will be simplifying algebraic radicals, radicals that contain variables. Now to start off, let's start off with a simple one. Uh, the simple one is, what would be, for instance, the square root of t to the sixth power? T to the sixth power. Well, when I think about it, all the factors of t to the sixth power, well, there's 1 and there's t to the sixth power. There's t to the um, first times t to the fifth. There's t to the second times t to the fourth. And there is t to the third times t to the third. And this pair is the winner because t to the sixth has twin factors, t to the third and t to the third. There's no need to go any further. I've found the winner. This is t to the third. Now, the astute watcher might realize that the index of a radical when there's no index given is 2. And since the exponent was 6, it would be easy to get that answer by taking the 6 and dividing it by the 2 to get that power of 3 without having to go through all these steps. And that would be absolutely right. So for example, if we were going through and we were looking at this problem here, let's say it was the third root of t to the power of 15, rather than going through all the triplets or all the three triples that I could multiply and get to t to the 15th, like t to the first, t to the first, and t to the 13th, right? Rather than going through and listing all those t to the first, t to the second, and t to the 12th, we could just think of what the triplets would be by simply taking the 15 and dividing it by the 3. So the answer to this would be t to the 15 divided by 3 is fifth power, because as it turns out, if we take t to the fifth and multiply it by itself 3 times, those triplets will actually give us t to the um, 15th power. So rather than going through and listing all the factorizations, we found it right away. T to the fifth times t to the fifth times t to the fifth is t to the 15th, and therefore the cube root of t to the 15th is t to the fifth. Now you might be asking yourself, what if it's not something that's divisible? That's the obvious question that arises. For instance, what if instead of the cube root of t to the 15th, I was trying to take the cube root of t to the 17th? Because 17 divided by 3 does not go evenly. This is a bit more difficult than the green one was. So what do we do? Well, the answer is we need to use the exact same theorem that we use when we're doing this with the constants. So when we were doing with the coefficients, we said that we can actually factor this thing. And that's what we're going to end up having to do now. We're going to end up having to factor it. And this is what we use for the factorization right here. So if the nth root of a and the nth root of b are real numbers, then the nth root of ab is equal to the nth root of a times the nth root of b. So I just need to find all the relevant factorizations. Let's go through and take a look. So for instance, I could break this up into the cube root of t to the first power times the cube root of t to the 16th, because t to the first times t to the 16th is t to the 17th. Or as the cube root of t squared times the cube root of t to the 15th. And this one seems promising actually. T to the 15th. And the reason why this one seems promising is because I know the cube root of t to the 15th. We just found that, right? And we could continue going like this. The cube root of t to the third times the cube root of t to the 14th. We could go through and just keep taking powers of t that add up to 17 until we're blue in the face. But the one we wanted was actually this one. I know that this list continues on, but the one I actually wanted, the one that we're looking for, is the one that I can actually simplify further. So this is the one I need. So this is going to turn into, let me see, this one we already said is just t to the fifth power. Well, this one has to remain under the radical as the cube root of t squared. And that would be how we would simplify that. So the t to the fifth comes out, and the cube root of t squared is what's left over. Let's try another. Alright, let's say we were looking at the cube root of x to the, let's say, 21st power. Oh no, that one's too easy. Let's say it were 22nd power. Well, we just break it down until we find one of the factors that the exponent is divisible by 3. So we start off with the cube root of x times the cube root of x to the 21st power. And right away I found one. This one here is magical. That's the one I need. That's the one I need. So this turns out to be, well, this thing you just divide. 21 divided by 3 gives me x to the power of 7. And this one stays the way it is because we just get the cube root of x left over. Alright, before we go on, let's just do one more. Alright, what if we were stepping it up a notch? What if it were the fourth root now of x to the power of, let's say, 23? So I'm going to split this up until I find a power of x that's divisible by 4. So let me see, 23 isn't divisible by 4, so I'll start with the fourth root of x times the fourth root of x to the 22nd. 1 plus 22 is 23, but that doesn't work because neither 1 nor 22 is divisible by 4. So I'll try the fourth root of x squared times the fourth root of x to the 21st. And that one doesn't work either because, once again, neither 2 nor 21 is divisible by 4. So I keep going and I look at the fourth root of x to the third and the fourth root of x to the 20th. And I think I may have found a winner. By virtue of 20 being divisible by 4, I can simplify this one. This one is simply, well, x to the, and when you divide 20 by 4, you get fifth. So that's x to the fifth. And the other part, the fourth root of x to the third power, just stays. Alright, so let's try one where we mix up the coefficient and the variable and see how that works out. So let's say I was looking for the cube root of 48 x to the power of, let's say, let's say 20. The 48 we can break up into two parts. It's going to be the cube root of 8 times the cube root of 6, because 8 times 6 is 48. And I know this one is special because the cube root of 8 is known. The cube root of 8 is 2 because 2 times 2 times 2 is 8. The other one where we have the 20, so we're looking for the cube root of x to the 20th. Well, I need to break it down, and it would be like x to the first times x to the 19th. That doesn't work. But then x to the second times x to the 18th. So I have the cube root of x to the 18th. 18 is divisible by 3. That's why I took that one. And that's times the cube root of x to the second. So everything here, this is the one that's special. This is the one I wanted, actually. So this is good because 8 times 6 would give me the 48. So the 8 times the 6 would be the 48 that I'm looking at. And the x to the second or times the x to the 18th would be the x to the 20th that I'm looking at. So now I can simplify. The ones that are easy to simplify, or the ones that can be simplified, I should say, are the ones I highlighted. The cube root of 8 and the cube root of x to the 18th. The cube root of 8 is 2. The cube root of 8 is 2. While the cube root of x to the 18th is x to the 6, because I just divide those powers. So that's where that comes from. On the other hand, this and this just have to stay underneath a radical. So the cube root has to have a 6 underneath it and an x squared underneath it because of those things there. And that's how we would go about simplifying that radical. So this would be actually the final answer here. Let's try one more. Alright, let's do the square root of, let's say, 50x to the 5th. So this is a square root. I know it's a square root because there's no index. I have to break up the 50. Well, the way I can break up the 50 is into the square root of 25 times the square root of 2, where this is the point, that's the goal, to simplify that into a rational number. And the square root of x to the 5th I can break up into the square root of x to the 4th, because 4 is divisible by 2, and then the other one would just have to be the square root of x. So once again, this is the one that's special because I can actually take the square root of x to the 4th. So let's do it. These two here I know. Square root of 25 is 5. Square root of x to the 4th is x to the 2nd. 4 divided by 2 would give you 2. Everything else stays underneath a radical. So the square root of 2 and x are what stays underneath the radical. And this is it. That is the final answer.